We've taken a look at motion maps before. We know that motion maps provide us with at least two things, and we're going to find out about the third thing. Motion maps will, one, give us a location of the object or position. They will give us some information about velocity. And we're also going to find that they can give us information about acceleration. We've already taken a look at the velocity vectors. We're now going to take a look at acceleration vectors also, or vectors or arrows. So let's take a look at how this works. Let's take a look at something like an object speeding up away. We know what that position time graph looks like. We know what that velocity time graph looks like. We know what that acceleration time graph looks like. So let's go ahead and take a look at those. Position time, velocity time, acceleration time. Speeding up away, that looks like that top opening parabola. We've got a nice sloping upward line, and this is a positive acceleration. Let's take a look at the position time graph for this, or excuse me, the motion map for this. So what we've done before is we've put dots to take a look at our location. Oops. We know if this is speeding up away, our spacing between those dots is going to get wider. So we'd go 1, 2, maybe 3, 1, 2, 3, 4, 1, 2, 3, 4, 5. Notice my spacing is getting wider, and then my velocity arrows are going to get longer. So maybe I go from 1 square to 2 squares to 3 squares to 4 squares to 5 squares. 2, 3, 4, 5. Yep. To 6 squares. 1, 2, 3, 4, 5, 6. These get progressively longer because it's speeding up. Now, the one thing we haven't looked at yet is acceleration for this. We know that acceleration, our definition of acceleration, is change in velocity over time. And each one of these is a unit of time. This is my at time equals 0, 1 second, 2 seconds, 3 seconds, and so on. So what we're going to take a look at is that change in velocity between each time frame. Keep in mind a change in velocity is going to be equal to v final minus v initial. So we're just going to pick two of these at random here. We'll start with the first two. This would then become my final. This would be my initial. So what I'm going to do is I'm going to subtract these two arrows, and I drew them of certain length so that it would be easier to do that. So here's what I'm going to do. I'm going to take that final arrow. This is v final, and it's 2 squares long heading to the right. And what I'm going to do is I'm going to subtract that other vector, which is 1 square to the right. Keep in mind that subtraction is the same as adding the opposite. So what I'm going to do is I'm going to flip that arrow around, and I'm going to add them together. I'm going to add this flipped around. So what I'm still going to have is, leaves me with this. And let me do this. So I get an arrow that's 2 to the right plus one that's 1 to the left. What I did was I took and I flipped this one around to be the opposite. So what I'm going to do is I'm going to add those up. And when I add these up, what I'm going to get is I'm going to get some cancellation. I've got basically like a positive 2 and a negative 1. So this cancels out this portion of it completely. And what I wind up with is an arrow that is 1 square long to the right. That is my acceleration vector, or acceleration arrow. It is 1 square to the right. It's basically the result of my change in velocity. So what I would do is I would go here and I'd put that right above there, 1 to the right. Essentially what I'm saying is that this increased by 1 to the right. This next one also increases by 1 to the right. Since I've got a constant acceleration, I know that all these acceleration arrows are going to be the same size. I can show that. Let's do it with this one here. To go from here to here, I'm going to have a final. This would be my final. This would be my initial. So it's going to be a final of, what is that? 1, 2, 3, 4, 5, 6. 6 arrows, or 6 squares to the right. And I'm going to take away, go 4 to the, excuse me, 5 to the left. 1, 2, 3, 4, 5, because I'm adding the opposite. So it's going to be 5 to the left. And I add those guys up, and I get all this cancellation. And I'm left with this right here of 1 to the right. Don't necessarily, actually, I usually don't put dots on those. But it agrees I've got a positive acceleration. This is pointed to the right, which is in the positive direction. This is my positive direction. And I get those acceleration arrows. Let's try this with another motion. Let's try this with steady away, or better yet, steady towards. We know what our graphs look like. Again, position time, velocity time, and acceleration time. This looks like this. This looks like this. And this is 0 acceleration. So for our position, or excuse me, our motion map with an acceleration arrow, we'll get something that looks like this. Here's my 0. Oops, we're headed towards. So I'm out here somewhere, and it's heading towards steady. So I'm just going to go ahead and make sure that this spacing is the same. And when I draw my, again, this is out at time 0. when I draw my velocity arrows, they all need to be the same size. So I'm just going to make these like 4 squares long. And to get my acceleration arrows, acceleration is change in velocity divided by time. So I'm looking at a change in velocity, which is again final minus initial. So I'm going to take these arrows. I'm just going to pick 2 of them, make one my final and one my initial, because I'm headed this way. This is at 0 seconds. This is at 1 second. That's at 2 seconds. So this is after this one, time-wise. This is at 2 seconds. This is at 1 second. So my final is the one that's after the other one in order of time. So I take that final, which is going to be 4 to the left, and I add the opposite of the initial. So that's going to be 4 to the left would be what it would be, but it's going to be the opposite, so it would be 4 to the right. And again, I'm going to add those guys up. And what happens is I get complete cancellation. So I get an acceleration of 0, which makes sense because, well, here's my acceleration time graph screaming at me that this should be 0 acceleration. So that means I've got 0 acceleration all along here. And to indicate that, I'm just going to put some zeros right above instead of some arrows. I'm just going to put zeros above all of these. Again, I could do that with any of these. I've got 4 to the left here, 4 to the left here. If I take this minus this, I'm going to get 0. So that's how acceleration arrows work.